I just want to make sure I'm the best prepared.
Yeah, good job. That's so good. Just being prepared is important. I can get everything shared here. What am I doing? Okay, I think I've got it. So I want to open a new file to start a new Python program. And this first one that I want to do is just going to be a little bit of experimenting for us. So let's just say script instead of program. We're going to call this one defensive programming. We talk about defensive programming, and defensive programming is our attempt to defend our program from invalid user input. So we know that if a user types something in for us and it's supposed to be a number and it's not, or it's supposed to be positive and it's negative, we have to defend ourselves and make sure that our program doesn't cancel because of that. So that's what this script will be. It's just some quick defensive programming. I'm going to put my name. It's so helpful there for me. And then our date. Hope it's 2020. My date jumped around. And finally, our purpose is to illustrate defensive practices. And then I'm going to put my 3 closing quotes to end that document block. Swear idle makes it easier to do the comments with the pound sign, but everything I read says we should do the 3 tick marks up here as our header comments, so we will. So for our defensive programming, we'll just do a couple things. Let's read a number in from the console. So we'll call that variable INP number. How's that? I'll start out and give it a value of 0. And then I'll use it as input. Now we want to have this input be an integer. So I'm going to convert it to an integer and use the input function to prompt our user. So I'll say something like, please enter a number. And then I need 2 closing parentheses to close both of my opening. And when we use that int function, we're casting that input as an integer. Now first, let's see if we can use the number as a divisor. We could print out 42 divided by our input number. So let's try that and see if we can run it. We don't have much fanciness going on, do we? I need to save it. It seems to have froze on me. Uh-oh. Trying to save? Before you were saving? The saving window didn't even pop up. It didn't. Did you not move it up? Is it right? Now we want to try entering a valid number. I'll try what 42 was our number we were dividing into, so that gives me a nice number of 1 as an answer. But what happens if I put in 0? Then it just crashes like crazy, right? Because I'm getting that division by 0 error. It's illogical. I can't do it. So what I could do then to be defensive is put an if statement before my division. So if my input number equals 0, I could print out a message like cannot divide by 0. And then I'll use my else clause to print out the answer to the division. Now let's try it. Again, if we put in a number like 42, we should get, whoops, where am I? Click 42. We should get our answer. This time, if we put in 0, we should get our message instead of it crashing. So notice the difference. When we're just writing here at the console, sometimes it's hard to tell. But when we put this 0 in up here, we got all these red error messages. It crashed like crazy. So if we were looking at a website or something like that, that would be really disruptive to the user, to the person that was using our site. But down here, since we're handling that error, we're able to continue on processing without being disruptive, without causing any sort of trouble. So that's what we mean by defensive programming, trying to keep it from crashing or having a runtime error, an unexpected failure. So let's try another one. We know that the book has told us we can't take a square root of a negative number. So let's do some square root processing. Can we get the square root? Now, the square root function is part of the Python math library. So I need to import that math library. I'm going to put it up at the top. Now that I've done that, I can print the square root. Let's see, I'll do math dot sqrt, and then I want the square root of my input number. So when I do straight math, I can just do that kind of anywhere. But when I'm using the math library, I have to follow its rules and pass in the number I want as a parameter so it's within these parentheses. Now let's run. And I'll do 45. So I got some answers. Now I'm going to run it again. I'll do my 0. I can't divide by 0, but I can get a square root of 0. It's still 0. But now let's try a negative value. So we were able to divide using that number. We got our answer. We might need to annotate that output a little bit more, right? Now that we're adding more to it, we need to add a little bit so it's meaningful. But here we are crashing again, where we are having this math domain error. That means that square root doesn't know how to do things in the domain of negative numbers in that value. So let's fix that. First, I want to put some better output notes. So in my print statement up here, I'll print the result of the divide operation. And then I'm going to use the comma to add more, because if you remember, Python doesn't like doing that math when it's outputting a string along with it, unless we use that comma or convert it to a string. So that'll be our easiest syntax. Now let's fix the problem with the square root. If input number is what? What can I check here to solve this problem? Less than what? 0. So that should do it. We'll print out a message. Cannot calculate square root of negative number. Else. The result of the square root operation let's run that. So let's see, I'll try a regular number. Oh, that looks much better. Now I'm seeing some good description so I know what's going on. I could run this some more. I'll try 0. Looks good. And I can run it again. I'll do negative 25. And then we'll get our divide, but not our square root. So that looks awesome. Let me leave that sitting there for a minute. Last week we did a sample application where we validated that a number was within a given range. That's something that we might have to do often. I'm looking at the textbook here. Make sure I don't leave any out. Let's try it. Now, I want to do a range check because a range check in if statement can be difficult. And we came up with all sorts of great ways to check that range last week using if statements and else clauses. But we did not, in a lot of cases, just come up with a straight if statement to do a range check, which is fine because you guys found all sorts of great ways to handle it. So let's do a range check here. And let's say if our input number is, let's say we want to find out if it's within the range 50 to 100. So I want to check to see if it's greater than or equal to 50. And I have to re-specify my variable name. And my variable name is less than or equal to 100. Let's print out a message there for that. Input is in range 50 to 100. Let's run that. And I'll do 50. And I do get my range message out, so everything looks good there. Now I'm going to run it again with 49. And we know we shouldn't see that message because we're not in that range, but we want to make sure that our if statement is correct. So then we need to check that 100 area. I could try 99. Yep. And if I run it again and use the value of 100, I should still get the message. And if I run it with the value of 101, I should not. Now, as you run your program, notice how important it is to know what results you're expecting, because we can't be sure that our program is working properly with our different test data unless we know what our output should be. Let's try another one. If input number is greater than or equal to, how about 101 and less than or equal to 150? Now, first of all, is our if statement valid? Let's run it and see if it's going to let us get by with that. I have to specify that variable name again. I can't shortcut and say, you can't figure it out. It's like, no, I cannot figure it out. You must tell me. Now I want to make this and an or. What'll happen then? Let's run it. I'm going to try my 100. My 100 says it's in both of those ranges. Try it. Do what? It's less than 150. So we have to always be super careful about that or. Whenever we're doing a range check, we normally want to use an and in our if statement. And that should fix everything up. that just gives us a few little samples of making sure that the input that we're processing is the input that we expect. And right now we're using the console and a console application, but we would have to do the same thing, you know, on the fanciest website that we've got. No matter what, we still have to do the same kind of validation. So these theories are important to us because no matter what we're working with, we're going to have to defend our code and make sure that we don't allow users to break it. So that's a good one. Let's save it and close it unless anybody's got any questions about it. If anybody's not working. I want to save it. Okay, another one that we've seen in this chapter that has gone on and on forever because we started Python this chapter. So we've done a little bit in our prelude to programming and thank you, and a whole lot of Python stuff. But at the beginning of the chapter, we used Raptor, and with Raptor, we calculated a paycheck. We used that to calculate overtime pay. So let's create that program using Python. I'm going to open it in Raptor so we can kind of review. So our Raptor flowchart, we asked for a pay rate or in hours, or those were our input variables. And then we had an if statement checking to see if the pay rate was less than $10 an hour and the number of hours they worked was greater than 40, then we calculated their pay using an overtime pay calculation. But if that was not true, like they made more than $10 an hour or they worked less than 40 hours a week, we calculate their pay using a regular pay calculation. So we're going to take this flowchart now and put it in a Python program. And so it shouldn't be difficult. Let's see if I can bring it up here beside it. I'm going to create a new file. And I'll say that this is our script payroll processing. And we'll say we're going to calculate overtime or regular pay. This is one that our test bank likes to do a lot with in our test bank, so we won't let it sneak us. Now we're going to start out with our pay rate variable. We'll set it to 0, and we'll set our hours equal to 0. And we'll go ahead and prompt for input. In our Python or our Raptor program, we didn't. We just set up our variables with certain values. But we can prompt for input here in our Python program. So I want to change to an integer whatever I get from the input function. And my prompt is going to be, please enter the pay rate. Now our pay rate normally would probably be a floating point value, but for simplicity for our program, we'll just make it an integer. Now let's read in the number of hours that they worked. Please enter the number of hours Now, because Raptor made us only enter the condition, we should be able to use that condition pretty much as is. So if pay rate less than 10 and hours greater than 40, we're going to use a variable total pay. So I'm going to go ahead and declare it up at the top with our other variables. And it also looks like we need overtime pay and overtime hours. Lots of variables. We'll look at them. Okay, so if our pay rate is less than 10 and our hours is greater than 40, we're going to do the overtime calculation. Calculate overtime pay. So the first thing we have to do is calculate the overtime hours. And we're going to set the overtime hours equal to the hours they worked minus 40, because 40 is a standard number of hours. Anything over that is overtime. Then we're going to calculate our overtime pay. Overtime pay equals our overtime hours times 1.5 times our pay rate. Now look at those two lines of code. Notice how important it is that they stay in the correct order, because first we calculate our overtime hours, and then in our second calculation, we use that overtime hours value. So we better have calculated it first before we try to use it. So anytime we're looking at a variable, we want to make sure that we're looking at a variable that has already been set up for us appropriately. We couldn't do these calculations before we did our input. Our input has to come first. All right, now that we've calculated these two overtime values, we can calculate our total pay, and it is going to be 40 times our regular pay rate, and then we're going to add in that overtime pay that we just calculated. Now we can do our else clause. So this is for people who don't get any overtime this pay period. We're going to calculate their total pay as equal to the hours times the pay rate. And that's like what we usually get paid, right? Now in our program, we need to output some information to finish this up. So let's do a print statement. And we could do some great things and tell everybody what's going on here. So let's say our hourly pay rate of, and then I'm going to do the concatenate function with the plus sign. And since I want to output a number, I'm going to have to cast it as a string. And then we'll say for this many hours. So that output should say our hourly pay rate of whatever our pay rate is for the number of hours, and then we'll add a description that says hours. I'll do a second line. Total pay will be now we're not outputting any of our overtime pay or hours calculations. We could add that in if we wanted to. But a lot of times it would just come out as 0, right? So let's try running this. We haven't done any testing. We just coded this whole thing without even testing it. So first we're gonna have to save it. So when I click run, I'm gonna be ready to save. Yes, I wanna save it. Overtime calc is what it was in Raptor. So we'll make this overtime calc in Python. And now, it says INP is not defined. What is it complaining about? Did I just abbreviate?
Yeah.
I can't do that. It can't figure it out. Silly Python. Okay, so then I've got enter the pay rate. We'll say to make $9 an hour, right? And 42 hours, because I want some overtime here. So now I've got to get a calculator because I used hard numbers. So again, I have to be able to validate my output. If I take 9 times 42, it's just a standard calculation, that comes out to 378. So I did definitely get some overtime here. So I could say I should have 2 hours of overtime. And my pay rate for my overtime should be $9 plus $4.50, right? 1.5 times my pay rate. So that would give me $13.50 for 2 hours. So the $27, which comes out just exactly right. So I can double check myself that way. Now I'm going to run it again and use numbers that should come out to a regular pay. 10, 40. Nice, I can figure that one out without the calculator. That's correct. So it looks like it's working okay. Our output looks really good. We're getting a lot of great information. Now looking at this program, I've got one here for you that's just a little bit different. Can you guys pass this out? We're going to try something here. What is wrong with me? I want to try some color coding. I have these pens, like old school. You might want to do it on Word or something. Try it. So I have this program printed out and a set of pen colors for each row. I'll try and share them. Right. So look very, very similar to what we've got here. So we can use the hard copy or we can use the online version. It's up to you. I've got this smart notebook thing open. And so the first thing I want you to do is, huh? Do what? You didn't get any? Is there any extras that we can pass back to back? No extras?
We had one extra.
Is there one extra? You already passed it? Let me print a couple more, no problem. I thought I had enough. So while we're getting those printed, I want you to use the purple pen to circle your pay rate variable every place you see it. So pass that purple pen down so that everybody in your row gets to use it. You guys can throw them out. Pay rate variable every place you see it. Purple, purple. Now pass that purple down, and after you've got your pay rate variable circled, circle your hours with the red. I'm using this smart notebook thing here on the computer to be able to circle, because you know, Word and stuff is just not very helpful, but if you think of one that will work, let me know.
It's almost easier to use the pens up there on the board.
Yeah, if the touch would work. I think the pens might work though. I just can't. I know it should, but smart little tools aren't loaded. I'm getting it here. Letting everybody get caught up. All right, so we're passing those around. Good job. Tell me, what is one special thing about those two variables? So there are input variables, so they're pretty special. So sort of like a constant, because we're getting it from the user. So once they input it, it's not going to. We're not going to change it. So, and that's a really good point, because sometimes we can get ourselves in trouble as beginning programmers by changing these variables that were our input variables, and then we can't figure out what in the world's happened to our input, because we wouldn't change those variables normally. That's a really good point. Now, as we go through and we see where we're using them, is there anything else special about them?
We use at least one of the two in every single line of code.
In every single line of code in the program, they're really important, right? That's absolutely true. They're really, really important in our whole application. They're also the ones we use to make our determination as to how the pay is going to be calculated, right? So they are our decision-making variables on how we want to do this. They're the variables that we use for all of the pay calculations. So they're very important. Now we can go through and do some other marking. We have some other colors of our overtime hours, pay, and all that. But instead, let's pass those out as much as you can, and whoever doesn't have any, use another writing equipment. I know sometimes we don't bring writing equipment to class because we don't use a lot of writing, but I want you to walk through this program now. We tested it a couple of times. I used the calculator. I'm going to try to write on the smartboard and see if it will let me. So how can I walk through this program? There's a couple of different things I can do. Because I've got this printed out already, I could just use this area right up here as my work area to keep track of what my variable values are. So I step through the program. If I didn't have that here and it was a longer program or something like that, I might write my variables down someplace else. I'm going to put them over here. So let's say I'm going to have my pay rate, my hours. That doesn't work very good. My overtime hours, and my overtime pay, and my last variable is total pay. Now, since I've got those written down, I can use them to walk through the program. So as I walk through the program, I start out and I see this output statement. That's just the informational. And then I see that I'm going to be prompted, what is the employee's hourly pay rate? What are we going to enter in? What do you want to enter in? 10. So now our pay rate is 10. The next line of code asks for our number of hours. How many hours do you want?
50.
How many?
50.
50? Okay, so now we know that the hours is set to 50. Next, we say, if our pay rate is less than 10, is that true?
No.
No. So I already know the if statement is going to be false. So I'm going to go to the else clause. And in my else clause, it says calculate the total pay by multiplying hours times the pay rate. So I multiply those two, and that gives me my total pay of 500. Okay, and then I'm going to print that out. So my output would be, if I were looking at a test question, my output would be the pay for this week is $500. So I would have to be really careful about specifying exactly all of those characters in my output. Okay, so what if we try different values? We can walk through this code repeatedly. Let's say we're running it again. What's our pay rate going to be?
9.
9? Okay, what about our hours?
50.
50. So in this case, is our pay rate less than 10?
Yes.
Okay, so now we have to check the other half. Is our hours greater than 50? Yes. So we're going to do these lines of code. So first we're going to calculate our overtime hours, which is hours minus 40. 50 minus 40, 10. And then my overtime pay is going to be those overtime hours, 10. Times 1.5 times our pay rate. So that's going to come out to 10 times 1350. So they're going to get $135 of overtime pay. Do it? 12, 13, 14, 15. I can't do math at the board, so you feel free to correct. Me and math at the board are not friends. Okay, so now I've got my overtime pay. So my next calculation is going to be my total pay. So for my total pay, we've got 40 times our pay rate, which was 9. Plus our overtime pay, which we just decided was 135. What's 40 times 9?
360.
Thank you. Sorry, it's getting messy. So a total of 495. Now, I'll draw this right there. Be all clean and neat. Hang on. I'm not a neat math person either, you can tell. So as I step through the program and walk through the logic, I could do that repeatedly, over and over and over, and check my results, make sure I'm getting it correctly. We as beginning programmers keep running the program over and over to get the right results, but really we need to be walking through the program over and over, making sure we understand what it should be doing, right? And then we can check and make sure that's what it's really doing. So as we follow these variables through our program, through our code, we know they have specific functions and what they are and how important they are. So that'll help us. Now, with the pens, I want you to think about what else could we do? Now, we have the ability to walk through our code like this if we wanted to. What other kinds of things could we do to really help establish relationships and things that are going on?
Wants to make it a flowchart again.
Do what? You can make it into a flowchart again. You could do that almost off to the side, right? We could. I know. Let's use the blue pen to circle any function names that are used in our code. So I'll go to blue and we'll pass this around. So first of all, print is a function name, and a hint is anything that's followed by an open parenthesis is a function name. So int and input, and if you want to just underline them, you could do that too. Make sure you can find them all. So I end up with 1, 2, 3, 4, 5, 6, 7. See if you guys end up with 7. The only other thing we have then are reserved words. So for us, our only reserved words are really going to be if. I guess we could count and else. So we look at our program, could break it down pretty easily into the different functions that we use, the variables that we're using, and our keywords. Program logic. Good, good, good. So I want you to think about how you can really emphasize things to yourself, whatever works good for you. Me know, and you can keep that or throw it away or whatever you would like to do. Let's see if we can do this. Okay, this Kahoots is Python fundamentals. So it might have a little code in it, which can make it hard. So you might want that Zoom session going. Guys, go. Oh, we should have some more. This is going to be a good one. I think we have everybody here today. Somebody must have thought it was a test. That's weird for us. Are we ready? No? Running pigeon. Oh, Corona, I should zap that one. Did you see the picture of the Independence Street Walmart this morning?
No.
It's bad. It's empty. Down the paper aisle, I don't know why everybody's so worried about paper products.
Right, me too. The big thing is not.
Are we good? Got 21. Let's try. Oh, there we go. 22. That's what I was waiting for. All right. So when there's code, it can always get sketchy. What is the Python programming language named after? Okay, I brought this one up. Oh, yeah. If they were here, they got it. What is the Python function to output data to the screen? Pretty evenly spread there. What will the following code produce? Don't forget about your Zoom session. If you've got it going, it'll help. Somebody's gonna have to fight that slow poking. Prod them. Keep getting like one each of the wrongs. What will this code print? This one's kind of sneakiness. We'll actually print it 3 times, so we haven't tried that. You'll use that a bunch next chapter when I ask you to loop things. Oop, got some switching going on. What will this code print? Checksum. What will this code print? Thank goodness. Didn't even give you any easy choices. Look at it go. Which line of code would print 32? Good. Doing this delayed thing. What will the following code print? Yeah, we just saw that with our pay calculation and stuff, so good job. What is a string? Good. Which data type only returns true or false? Exactly. Let's see how that works. Woohoo. Ah, yay! Yay! Oh, good job. You guys were right there. Okay, so that was our Python fundamentals. Keep your Kahoot's hat on. And let's look at if statements. Bad attitude. Have to get that person some counseling. What's that? Good, you'll hear it referred to as both. What is the and? Very good. Logically combining the conditions. Woohoo, look at it move around. What is that? Very good. When we only have one of them, it's assigning a value. what is that part? Very good. It's part of the condition. Competition up here in front. An if statement is a good. Fighting it out. An if statement with an else clause is but he's going crazy. False is a that was a speed war. Clicking when it started. Good job. Is Zach taking over? What's that? Good. Confusing, but we'll see it. A case statement is good job. Just fighting it out. Which is the assignment operator? Woohoo. CH is dancing. Vincent's right up there. Woohoo! Who won? Oh, you guys are just right there battling it out. Good job. They were. Okay, that one was good. Woohoo! All right, so we see how fun it is to do Kahoots and coding. Sometimes it's good, sometimes it's frustrating. In our Canvas course, I can find it. I thought I had it up, but it looks like I've closed it. That's so unlike me. It is. I never close anything. I'm going to do this practice exam, so you should do it with me instead of you doing it yourself, because if you do it yourself, you're going to get different questions than me. But if we all kind of do it together here on the big screen, we can just look at these same questions and decide what our answers should be, and we'll run through it real quick just so you see what the practice test looks like. For number one, the multiple alternative selection structure that does not use an if-then-else clause is the blank or blank statement. Switch your case. And yeah, I don't know what it wants. And that's why there's a practice test so we can see. And sometimes with these written ones for this particular test, I just have to look at every single one and see if you got it right or not. Huh? They don't have any sort of good consistency in our test bank. So a lot of these, you know, just remember when you take it, if it scores you low, I'll be looking at all of these fill in the blank ones individually and correcting the answers. So I definitely do have to look at this one, every single one, because it does not do a good job at scoring. Okay, so the integer 16 has a reciprocal. Is that true? What type of operators that are evaluated second in the hierarchy of order of operations are logical operators? Is that false? Which of the following will make the given statement true? My name is less than or equal to your name. If my name is Lizzie and your name is Lizzie Beth. Now, this is an interesting one. Notice how Canvas has reordered these answers, and it says all of the above make the statement true. Well, we know it just means all of the others, right? So we won't get too upset with that. My name equal Lizzie and your name equal Lizzie. Those seem pretty equal. My name equal Lizzie and your name equals Tizzy. Do what? All of the above? Okay. Because we have the less than or equal. That one would be correct. Good job. The greater than or equal sign is one of the, do it. Relational, that's fine. That's more correct, really. An if then else selection structure, at least one line of code will always be skipped. What is the output of the code corresponding to the following program segment if age equals 18? First of all, is our if statement going to be true? Yes. So we should see output, you are eligible to vote. Question 8, true or false? Given that x equal 14 and y equal 15, is the following true or false? So let's just break it down. X greater than y. Is that true? No, that's false, but we have an or condition. So we have to look at the next one. Is x greater than 0? Yes. Okay, so this half, this or half is true. Now, what about the other half? Is y less than 0? No. So we would say it's false. If you need a piece of paper or something to write them down, just ask for one so that you can scratch things like that out. Now, this one is written in kind of a confusing way. Given the following program, choose the line necessary to replace the asterisk so that the program segment will ensure that an illegal operation does not occur. We want to prevent one of those runtime errors. First, we prompt by saying enter a number. Then we tell them the square root of that number will be displayed. And then finally, we read in their value into our variable my number. Now, these lines of stars here are what the question is referring to. What should be on that line of code to make sure this thing doesn't cancel? Because it's going to do a square root calculation. Greater than 0?
I guess it's greater than or equal to.
Yeah, so it'll be okay. That sounds good. So that if statement is what needs to go there to keep that program from crashing. Question 10, what will be displayed after the following program segment is coded and run, assuming the user enters the number, enters the number 49 at the prompt. We've got a prompt, enter a number, the program will display its square root. We read in the number. So we're going to see this message, the square root of 49 is 7. That's good. What about question 11? Is Joan less than or equal to Jane? Because O is greater than A. Number 12, given that Marcy worked 42 hours and earns $10 an hour, how much did Marcy earn last week before taxes? First of all, is our rate greater than or equal to 10? Yes. Is our hours less than or equal to 40?
Doesn't matter.
No.
Rate is equal to 10.
Oh, it's an and, so it does matter. So we have to have both conditions. So greater than or equal to 10 is true. Hours less than 40 is false. So we're going to do the else thing. So doing our calculation, our rate is $10 an hour. So rate times 1.5 would be $15. We're going to multiply that by the hours minus 40. So we had 2 hours at $15 an hour, which is $30, plus our original 40 hours at our $10 an hour. So that would be 430. Again, if you need a piece of scratch paper, it's fine. 420.
Your math is correct, but the answer is 400.
Well, it should be 430. We should fix it, huh?
The question's not asking for the 430, it's asking for 420. Sure. Yes. She earns $10 an hour.
Yeah.
She worked 42 hours. If the rate is greater than or equal to 10 and the hours are less than or equal to 40. Oh, never mind, you're correct. I misread the top.
That's okay. I was like, wait, what am I missing? These questions always get me.
Yeah.
Logical operators are used to create blank conditions from given blank conditions. Something about simple. What was the first thing you said? Complex from simple. Perfect. If number equals 8, what will be displayed after the following statement is executed? Set reciprocal equal 1 divided by number, and then it looks like right reciprocal. So kind of ugly code. What are we going to see? Fourth option, error message, one of them.
Well, 1.8 is 1.25. Yeah, but it needs to be turned into a string for it to be written. Exactly. Python allows you to write the. Yeah, so if you take it like this before, you just can't write it 1.25.
Okay. And remember, this is actually ugly pseudocode, not Python code, because I've got that right keyword, which Python doesn't have. So I'm really pseudocoding here. So even worse. So let's see number 15. If my name equals Bunny and your name equals Buddy, which of the following is not true?
Extra challenge. We can solve the problem without even looking at the base answer to the base question.
So first of all, which one is greater? Bunny or Buddy? Bunny. So we know that Bunny is greater than Buddy. So which of the following is not true? My name greater than your name. That one is true.
My name is less than your name. It's the false one.
The very last one. Number 16, if a division operation is performed in a program and the divisor is 0, execution will halt and an error message will be displayed. True. The assignment operator and the comparison operator use the same character. This one is super confusing. They both use the equal sign. They just use a different number of them. So I say true, but I could be wrong. We'll see what it wants. If A equals 20 and B equals 15, then both the following statements are true. A is greater than B. Yep, that's true. B is less than or equal to A. Yep, that's true. 19, a statement which checks to see if the value of the expression on the left side is the same as the value of the expression on the right side is an example of the do you want comparison or do you want the two equal signs? I think it was wanting the two equal signs. Yeah. Does it want the word? We'll fix it. The order of operations for blank blank is not first, then and, then or. Perfect. If my age equals 30 and your age equals 40, which of the following is a true statement? Not my age greater than your age. That one seems true. My age equal 23. Well, that one's not. My age greater than or equal to your age. So it's this first one. Now, I will really try to force my brain to do that with a programming exam. Even if I know this answer is correct, I will read through the others to be sure there isn't one that's not more correct. Because sometimes when we're working with programming, we have to choose the most correct answer and not just a correct answer. So I always try to read them all. 22, a selection structure consists of a or and blank blank together with one or more blocks of statements. Yeah. Want something along those lines, the if else. One type of illegal operation is what? Say it again. Thank you. I don't mind looking at. Sometimes this thing makes me crazy. One type of illegal operation is an attempt to take the square root of a or an blank blank. We got that. Number 24, which of the following will make the given statement false? My age greater than your age. If my age is 23 and your age is 35.6, that would make it false, right? If they're both 23, that would make it false. If my age is 23 and yours is 24, that would make it false. So all of them. And lastly, and blank blank is used to summarize the actions of the logical operators.
It's the truth table.
I had no idea. So the truth table is where we list all of our possible outcomes of our if statement based on true values or false values, so we can make sure we've got test data to test all of those possible outcomes. We'll see why we got to do this practice test. Right off the bat, huh?
Yeah. And they want to separate.
Yeah, and like I said, I'll be checking it. So don't worry. So the question about the greater than or equal would take comparison or relational. Looks good. Okay, compound, comma, simple. So I guess they're consistent that they do want a comma in between the two words. Oh, and I did that, and you guys were saying, no, it wants relational comparison. You were on it. Good. That should do it. Okay, great job, everybody did. I'm gonna.
And that practice test we take more
and more. Yep, you can take it as many times as you like, and it'll pull different questions from the question bank for you.
The reason I ask is because when it wants very specific wording, like in the example at the top, we had switch and case, but it wants case, comma, switch, and apparently capitalized.
Yeah, and like I said, that's why I'll go through them all on this one, because it's just a real bear. There's no way that you guys can do a really good job and do commas and things like that, but it's still like impossible to get some of the ones the way they've got them. So I will double check them all. If you get it right, exactly matching, then you'll know what your score is. Otherwise, you'll have to wait a little while till I look at it. The hands-on exam is a Roman numeral program. And remember, it's just input and output. It's not a number unless you say it is. So you don't have to tell Python it's a Roman numeral. But we want a program that'll prompt the user to enter a number in the range 1 through 5. Then the program should display the associated Roman numeral for that number. Notice there's not a lot of requirements for your output. Just should specify, you know, the number that the user input and then the Roman numeral. You just need to turn in your Python file. Because this one is a Python program, your rubric, look at it, will help a little bit. So let's make sure we get all of these things done. First of all, this proper care is demonstrated basically means that you got the program submitted to Canvas, it's a .py file, and I can run it. Comments are 5 points, don't lose them. No logic errors. This is the majority of our points that the program works and runs and does all of that kind of stuff. The implementing concepts in our unit. Right now, we're beginning with Python, so there are no specific concepts. If you get this program to work, that'll be taking care of it. And then following naming and coding conventions just means that you'll use the same kind of variable names and names that we've been using that are meaningful in your code. So that's how you get your points. So if your program doesn't work, worst case scenario, you fought with it and you can't get it to work, you can message me on Discord and I can take a look, that's fine, and see, you know, if it's something that's not too major. But if it's just you're out of luck and out of time, it's only these 30 points here that are totally affected by the program not working. And I'll look at your code and see how close it is and give you some of those points. So don't turn anything in. Always turn in your best attempt, because sometimes we run out of time and still should turn it in. So you might get the majority of the points. Google Chrome decided to make my screen black for me. It popped up with a little message and said it's assisting me while I present. Whoops, that's helpful. You can see it. I can't. You can start working on it now. That is not a problem. Good question. So anything like that that you want to work on, do. And Thursday after the exam, if you want to stay and work on it, do too, you know. I mean, if you would rather be at home, that's fine too. Just remember, if you get that panicky feeling when you're all alone, you should do it here. So you've got that little bit of support to get that thing done. Okay, I'm gonna fight with my computer, figure out why it went to black. Any questions? Yes, sir?
Is it possible that we could round up our respective study groups and talk out the problem?
Yes, very good point. And I meant to bring that up. We have our study groups. If you go to your study group page and create a collaboration document, you can spend the rest of this time getting some notes put together, if you like, for your collaboration document about this exam. I know in Unit 1, I had those all set up for you. It's a lot better if someone in your group creates the document and shares it with everybody else. It seems to work. Or you could continue on in your Unit 1 notes and just add more for that. However you would rather do. Other questions? Your study group notes, yes. Just again, make sure there's no like actual questions or anything copied into them. Just notes, which can be hard when you're looking at the practice exam. Okay.